Hi there everyone, and welcome back to this factorization lesson, and we are looking at the factorization's second law, okay, which is the difference between two squares. Now remember, we can only have the difference between two squares if there are two terms, okay, because we talk about the difference between two squares, okay. So there are two terms. There is a minus between them. See the difference? That means minus between two terms. And you can get the square root of each term. That's why they call it two squares, because we can get the square root of the first term and of the second term. So please remember, when you must factorize, always check for a common factor first before you do any other. That you have to remember, okay? So now, what are the steps to do the difference between two squares? First of all, get the square root of the first term, the square root of the second term, and put it in brackets. Okay, wonderful. So let's look at the examples for the difference between two squares. Well, there's no common factor between these two terms. So again, what's the square root of x to the power of 2? For those of you who don't know, I'll quickly show you for the last time. Because if we want to get the square root of x to the power of 2, that is simply that 2 divided by that 2, which is 1, right? So my answer will be x. Because we take that 2 and we divide it by the square roots 2 that is invisible there, right? Okay, and 2 divided by 2 is 1. So basically we get the square root of x to the power of 2, which is x. We write the minus down and we get the square root of 16, which is 4. And according to the steps, we put it in brackets. So let's put it in brackets, but we're not done. Rewrite that bracket. So we're going to rewrite this bracket, but instead of the minus, make it a plus. So we rewrite this exactly the same way. And instead of the minus, we are going to put a plus there, and we are done. Okay, wonderful. And you can see that the reverse of the difference between two squares, if we want to go from this back to that, will be a product of two binomials. And it will be the quick one, because we have exactly the same things in the brackets, only the signs change. So the first times the first gives me that, and the second times the second give me that. Okay, you remember that from the multiplication lessons? Awesome. Now here, again, we have a difference between two squares. There's no common factor, because please remember, when you must factorize, always check for a common factor first. There's no common factor between those two terms, but there's a minus. There's two terms. I can get the square root of that one. I can get the square root of that one. So this is a difference between two squares. So let's do that. So what is the square root of a to the power of 4? That will be a to the power of 2. And then we write that minus down. Yes, there we go. And we get the square root of 16b to the power of 8. The square root of 16b to the power of 8 will be 4b to the power of 4. We put that in brackets. We rewrite this bracket and we change the minus to a plus. And are you happy? There we go. But please don't just stop. Always go and look inside the brackets. There you can easily see that this is also a difference between two squares. There's a minus. We can get the square root of that one. We can get the square root of that one. But not for this, because there's not a minus, right? Because remember, we can only have the difference between two squares if there are two terms. There is a minus between them, and you can get the square root of each term. So let's do that. What's the square root of a to the power of 2? That will just be a minus, what's the square root of 4b to the power of 4? That will be 2b to the power of 2. Put it in brackets, rewrite this bracket, change the minus to a plus. And then what about this last bracket? Can I just forget about it? No, I have to write it down. So that will be a to the power of 2 plus 4b to the power of 4. And now I am done. Okay, brilliant. How about this last one? There is no common factor between that term and that entire term. So we go to the next factorization law, which is the difference between two squares. There's a minus. There's a term where I can get the square root of 4. There's also a term where I can get the square root, because I can get the square root of this entire bracket, right? And I'll show you quickly here at the bottom how to do that. So if you have brackets, which is a plus b to the power of 2, and we want to get the square root, it will simply be this 2 divided by that 2, which gives me 1. So we write the base a plus b, and it will be again that 2 divided by that 2, which is 1. So it will be to the power of 1. And when anything is to the power of 1, we don't have to write that 1, right? So just to show you that we can get the square root of that. It's the same as if we just have a number to the power of something or a letter to the power of something, then we can get the square root. So what's the square root of 4? It will be 2 minus, what's the square root of a plus b in brackets to the power of 2? It will just be a plus b. And then we have to put these two answers just like here in brackets. So I'm going to put those in brackets, and I'll show you with blue brackets. There we go, and we rewrite this entire thing just the way it is there. Okay, so I'm going to rewrite this. And why did I use the big brackets? Because I have smaller brackets on the inside. So, and look very closely. I didn't do it now because I'm going to show you. Remember, when you rewrite this bracket, that minus there needs to change to a plus. Okay, there we go. So now we are almost done, because in the big brackets we've got smaller ones, so we can multiply. So we leave the big brackets, 2 minus a minus b, and here we have 2 plus a plus b. Do you know how we got there? Because the minus times the a and the minus times the plus, right? And the same there. So we ended up with these brackets, because in the big brackets we've got two terms, and that is a distributive law to get rid of the brackets inside the big ones, right? Okay, awesome. So let's go and try some more examples. Now here are some examples that you can try. Give them a go, and please remember, always check for a common factor first before you just start factorizing with other things, right? Okay, so here we have two terms. There's no common factor. Is it a difference between two squares? Yes, it's a term minus another term, and I can get the square root of that one and that one. So this is easy. It will be 2x minus 3. Put it in brackets, rewrite the bracket, and change the minus to a plus. And I'm done. Now, how about this one? There's no common factor, but it is a difference between two squares, because I can get the square root there and there. So let's do that. This will be a b, and then minus, and that will be just 2a plus b, right? Put that in brackets and rewrite this entire thing and change the minus to a plus. And close the bracket. Inside the big ones, we don't want smaller ones, so we have b minus 2a minus b, and then we have b plus 2a plus b. And look, don't just stop. There's a b and a b, and because we're just adding and subtracting, yes, we can. A 1b minus a b is a 0. So in this bracket, we just have a minus 2a left. And how about this one? There's a b plus a b, which gives me 2b plus 2a. And then we can do something even more funny here. We can take out a common 2 from that bracket. And if I do that, look very closely. I take out that 2. I'm going to multiply that 2 with that minus 2. And it will become a minus 4a. And then we have b plus a on the inside. Okay, so I hope you could follow. This was a nasty little one, because in the beginning we couldn't take out a common factor, but there all of a sudden, after we did all of this, a common factor existed. Okay, so please keep that in mind. Always check what's in your brackets. And now, how about the last one? Well, this one has a common factor, right? So make sure that when you factorize, you always check for a common factor first. And this one does have one. So what is the common factor between 16 and 4? It will be 4. We always start with the numbers, then we go over to the letters. There's a A, there's a A. We can take out a A. The most A's I can take from both sides is A to the power of 1. So I take out that A, and that is the highest common factor. So we open up brackets, and then we take the original term divided by that. So 16A to the power of 3 divided by 4A will give me 4A to the power of 2 minus, we take that one divided by 4A. So 4 divided by 4 is 1. A divided by A, we cancel the A's, and it's just B to the power of 2 left, right? Okay, wonderful. But now we're not done yet, because in these brackets we have a difference between two squares. So always leave your common factor. You leave it, you don't touch it again, you took it out, so just keep writing it down. And then in these brackets we can get the square root of 4A to the power of 2, which will be 2A minus, we can get the square root of B to the power of 2, which is B. Put it in brackets, rewrite this bracket just the way it is, but change the minus to a plus. And now we are done. So I hope you could follow, and hope to see you in the next lesson. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.